this tutorial, we will be discussing alkanes with substituents. They call it a substituent because it's a substitution. So here, for instance, this hydrogen right here is getting substituted with that CH3 group. These are actually considered structural isomers. They have the exact same chemical formula, but they look different. Either way, we have 1, 2, 3, 4 carbons and 1, 2, 3, 4 carbons. We both have 10 hydrogens. And this one has 10 hydrogens. But they don't look alike, and that's what's making it a structural isomer. This is considered a straight chain, while this one's considered a branched chain because it has a substituent coming off of it. Remember, substituent is given that name because it substitutes one of those hydrogens. So let's try to draw 3 possible structural isomers of pentane. What I like to do is draw the carbons out first and then try to arrange it. So I draw the straight chain first. 1, 2, 3, 4, 5. There's my 5 carbons. And those are all hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And the last one, 1, 2, 3, 4. Every single one of those carbons has 4 bonds coming off of it. If we add up all the hydrogens, we count 12 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so now let's try to do substitutions. I'm going to take this carbon at the end, and I'm going to move it. So instead of having 5 in a row, I will now have 4 in a row. And I have to figure out where I'm going to move that 5th carbon. If I move it here, I haven't changed anything, because no matter what, I still have those 5 in a row. So that doesn't help me any. But if I move it here, now my base is 4 carbons in a row rather than 5, so my base is a butane rather than a pentane, even though I still have 5 carbons. Now I have to fill in the rest of the hydrogens. 1, 2, 3. 1, 2, 3. I need 4 here. 1, 2, 3, 4. 1, 2, 3, 4. All of those get hydrogens. I still have this carbon right here. I need 4 lines coming off of it. So 1, 2, 3, and then the 4th is going to the other carbon. So there's one isomer. I want to go through that entire process again because I'm looking for 3 isomers. So here's 2. We have the straight chain and we have a branch chain. We can have one more out of here. So once again, I'm going to take one of those carbons away, and I'm going to move it. So instead of having 4 in a row, now I'm only going to have 3 in a row. I can put 1 carbon up here and 1 carbon down here, and suddenly I still have 5 carbons. The one in the middle already has 4 bonds, but we can put 3 more hydrogens on the outsides of each. And that's how you determine what the isomers are. You just take it step by step, trial and error. As I said before, the one thing you don't want to do is take it from one side and put it on the other side, or put it up or down thinking that you're actually changing it, when in reality you're just bending the chain. Substituents are atoms or groups of atoms attached to the carbon chain and include alkyl groups and halo groups. An alkyl group is a group of atoms attached to carbon chains. So it's carbons attached to carbons like we did here. This is an alkyl group. Halo groups are halogen atoms attached to the carbon chain. We name those with the first of the base of the word. So instead of fluorine, it's fluoro. Instead of chlorine, it's chloro. The alkyl groups end with the YL. So for instance here, one carbon is meth, so it's methyl. Two carbons is eth, so it becomes ethyl. Three carbons is prop, so it becomes propyl. Isopropyl is a substituent or a category of propyl. Iso means that it's the same on either side. And then here's our halogens: fluoro, chloro, bromo, and iodo. What I typically do, this is the process I use. The first thing I do is try to figure out the longest chain. There's my longest chain. I don't have any carbons coming off this side. I don't have any carbons coming on this side, so I don't have to worry about it bending. So I have 1, 2, 3, 4, 5. So that gives me 5, which is pent. So that's pentane. Then after that, I circle the substituents. So I have one here, and I have one here. All the rest of them are hydrogens. Cl is chlorine, which is chloro. CH3 is methane, which is methyl. Now this is very important. You're going to want to figure out what direction to count from. We can either count from this direction, from the left, or we can count from the right. You want to count from the direction that meets the substituents first. If we count from the left, we have 1, 2, and we have a substituent chloro. If we count from the right, we have 1, 2, 3, and we have the substituent methyl. 2 is smaller than 3. And so therefore I'm going to use that as my starting point. So that means this is going to end up being 2 chloro. So it's 1, 2, 3, 3 methyl. From here, look for the alphabetical order. Chloro versus methyl. Alphabetically, which one comes first? C comes before M, so that's going to be written first. 2 chloro. It has nothing to do with the numbers. It has to do with the letters. 3 methyl pentane. It's very, very systematic. Each thing tells you something. Keep that in mind as you're doing these. It's a puzzle that you have to put together. When naming cycloalkanes with substituents, when one substituent is attached to a carbon atom and a cycloalkane, the name of the substituent is placed in front of the cycloalkane name. So this is cyclohexane. This is an ethyl group because there's 2 carbons, so it's ethyl cyclohexane. If there's only one group there, you don't have to worry about numbering it. You only have to number it if it's 2 or more. Haloalkanes are alkanes with a halogen atom that replaces a hydrogen atom. They're named by putting the substituents in alphabetical order. So chloromethane, bromomethane, fluoropropane. Whichever one is alphabetically first is the one you'll put first. Let's try to do this the reverse way. Let's see if we can take the name and draw it. I typically work backwards, so I look at the right-hand side first. Heptane is 7, so I'm going to draw 7 hydrogens. Okay, so I'm done with that part. Dimethyl is telling me I have 2 methyl groups. So I have 2 groups with 1 carbon. They're on carbons 1 and 2. So here's 1, here's 2. CH3 here, CH3 here. And then 1 chloro, Cl. Alright, so from here, you fill in the rest with hydrogens. I just noticed something as I was writing these out. The textbook did not catch this error. When you're looking at this, the straight chain here is not hept. It's actually oct. This should be our straight chain. So it should actually be it should be 2 chloro, 2 methyl, octane. That's a mistake the book makes, but you know what, that's okay that we find these errors, because that means we know what we're talking about. Let's try this again. 3 bromo, 1 chlorobutane. But means 4. 3 bromo, so 1, 2, 3 bromo, 1 chloro. All the rest of them are hydrogens. It's saying the condensed structure, so technically this should be CH2Cl, CH2, CHBr, CH3. Something I want to point out in this particular one, alphabetically, bromo comes before chloro. Even though numerically, the first carbon is first, they put in alphabetical order when they do these. Alright, let's do a couple more and then we'll be all done. First, find the longest chain. Here's my longest chain. 1, 2, 3, 4, 5. My longest chain is pentane. Counting from the left or from the right, you get to the chloro faster if you go from the right. So 1, 2. 2 chloro, pentane. Okay, here's this one. 1, 2, 3, 4, 5. That's pentane again. Count from this direction. We hit it on the second carbon. Counting it from the right, we have to wait to the third. So it's going to be 2, 3, because these are both methyl groups. So it's going to be dimethyl pentane. And that is how you name alkanes with substituents.